Hey everyone, welcome back to my channel where we are here to dive in the world of data science and machine learning. Today we are tackling an exciting topic which is called as dimensionality reduction with PCA to optimize energy usage in smart homes using IoT data. Let's just jump in right. So first of all, we need to understand what is a PCA. So a PCA is a principal component analysis. I know this might sound like a rocket science, but trust me, it's not. Let me break it down for you. So now imagine you're at a huge mall with hundreds of shops. Each shop represents a feature of data. Now you want to summarize everything that's happening in the mall without visiting all the shops. That's where PCA comes in. It's like finding a few points in the mall that gives you the whole picture. So the real power of PCA is it works more than two features. Let's say it's like hundreds of features like energy usage, appliance status, temperature, humidity, light, etc. The PCA finds pattern in it and combines them into fewer dimensions, keeping only what really matters. So now let's just jump into our code. As you can see, we have a data set loaded here, and I have imported four libraries: pandas and preprocessing standard scalar, PCA, and matplotlib for visualization. I have loaded the data set here in CSV, so pd.read_csv. pd means it is a pandas data frame. So next one, we need to exclude the target variable as we don't need that variable. So x means the data is equal to data dot drop of columns appliances. This means that the column which has appliances in the dataset has been dropped. Now let's see about standard scalar. So now let's see about standard scalar. So the standard scalar has been used because the features in our dataset may have different ranges. For example, a temperature may range from 10 to 40, while the energy use could range in thousands. To ensure that all features are treated equally, we need to use standard scalar to normalize them. So I have used a standard scalar here. The x scaled, I have created a variable, the x scalar dot fit underscore transform of the data set. I have fitting it here, that is the reduced data set. Now let's go to the next step. Before going into the next step, this step ensures that the PCA results are accurate. Unscaled data can be biased in analysis. That's why we are going for a scaled data. Now the next step, PCA for dimensionality reduction. I already told you what is a PCA. So here we apply the PCA value as 95%. That means that the PCA to reduce the dimension while keeping the 95% of the variance. This means we are preserving the most important data information from the data. So xpca pca dot fit underscore transform x scaled data reduced data set here, and n components is equal to 0.95, which is 95%. Now next, step 4, inspect the explained variance. Let's have a print that explains the variance and number of components PCA has been selected. So explain variance PCA explained underscore variance, it will give the ratio here. We are printing it, explained variance here, and the number of components, like 0.95, the PCA n underscore components 0.95 here. Now we will see how the visualization takes place. As you can see, the figure size is 8,6 plt.figure, and I'm plotting it range from 1 to length of the explained variance, which is here, and each of the variance have to plus 1 increase, and explained variance dot come sum, it will sum the variance, and marker it will be O, which gives here the O, and line style is hyphened. As you can see, it has been dotted. So the title is cumulative variance by principal components. X label is number of principal components. Y label is cumulative explained variance. plt.grid, you can see the grid, and show it, you can see the graph here. Now this is the last step. We need to save the reduced data for further usage. Alright, now let's talk about what is happening in the step 6. There is where we take the reduced data from PCA and save it for a future use. First, we are creating a new data frame using the result of the PCA. Remember XPCA here. So we are using it here, and columns F PC I plus 1 for I in range X underscore PCA dot shape 1. So that means this one is a fancy way of naming the column dynamically. That means if the PC has given the value 5, it would be like P1, P2, P3, P4, P5. And for in range, it is like a for loop which has the loop for a which can dynamically change according to the shape. Now the reduced PCA, we are saving it as .csv, and it already has an index. So when downloading it, this data set will produce a new index. So we are keeping it as an index false, and dimensionality reduction is complete. Reduced has been saved to a reduced data frame. So here the explained variance has been given, and the number of components selected is 11. I've told you for 5, so for 11 it is P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11. As you can see the line, and dimensional reduction complete. Reduced data has been saved to reduced energy data.csv. That's it for today. We've taken a dataset with multiple IoT sensors, reading and reduce the complexity using PCA. This is a great starting point for energy optimization, clustering or anomaly detection. If you find this helpful, hit the like button and subscribe for more data science tutorial. See you in the next video. Thank you.